Hey again, Methods students. So yet another example of a cosine graph. This one that we're trying to sketch, again just for one cycle, is y equals cos of pi on 4 minus x plus 2. So probably not a big fan of the way what this equation's written, because typically what we like is to have x appearing first in the bracket and with a coefficient of 1. At the moment it appears second and its coefficient's -1. So let's rearrange the equation a little bit, or at least rewrite it how we would like to look at it. So I'm going to do that as a first step, just to put x first, and then as a second step, we're going to take out the factor of -1 because we want x to be on its own and positive. But when we take out that factor of -1, this plus pi on 4 becomes minus pi on 4. Right, and so when we look carefully at this rule, well, a couple of things that we've now identified really clearly. One is that this graph will be translated by pi on 4 units to the right because it's x minus pi on 4. But we've also got a negative, I guess, inside the bracket here, which is going to give us a reflection in the y-axis. So we're going to have to think about what that looks like as well. Right, as we've been doing in the previous examples, before we start sketching, let's just take some quick mental notes here. So we said we've got pi on 4 units to the right shift. We've also got a shift of 2 units up. We've got a graph that has an amplitude of 1 because it's 1 times cos x, and we've got a period of 2 pi over, and the n value in this question is 1 as well, so the period is 2 pi. And when we think about the shape of the graph, if we have a cos graph that's reflected in the x-axis, well, usually a cosine graph starts at the top and sort of goes, down like that and does the same thing over here, right, and comes back up. And if we reflect that in the y-axis, we're actually going to get the same graph, right? Reflecting that in the y-axis doesn't do anything because this is a mirror image of itself in the y-axis. So our shape is going to stay looking like a positive cos graph, even though it's a negative cos graph. Even though it's a cos graph that's reflected in the y-axis. So to build up our reference points, again, we're just going to think of this as the graph of y equals cos of -x. So we're going to think of the equation without any of the translations. And if we mark those reference points onto our graph, we know that it's going to start at +1. Okay, come down to its mean position, then drop down to -1, come back to its mean position, and then come up to +1, and that would be one cycle of y equals cos of -x, remembering that that reflection in the y-axis hasn't really had any effect. Just in case we need them, you can also mark in a couple of extra reference points going back to there. All right, now what we're going to do, take all of these points and move them pi on 4 units to the right and 2 units up. And actually what I should have done before starting to do all that is mark in some x-axis values. So we said that one period of this graph is 2 pi. So there's pi on 2, and 3 pi on 2. And -pi on 2. So let's start with our point at x equals 0. We're going to move that by pi on 4 units to the right, and then 2 units up. All right, so it's going to end up here. And all our other reference points just do the same thing. So next one, pi on 4 units to the right, 2 units up. This minimum down here, pi on 4 units to the right, 2 units up. This x-intercept, pi on 2 pi on 4 to the right, 2 units up. All right, and I always find these flatter ones a bit harder to sketch, but let's see how we go. We've got almost a full cycle here, but we're going to have to go back and use at least one more reference point. So let's use this one here. We take it pi on 4 to the right, 2 units up. Sorry, pi on 4 right, 2 units up. We're going to end up here. And there's one full cycle of the graph of y equals cos of pi on 4 minus x plus 2.